Hey guys, welcome back to another Vlesson. Super exciting. Previously, we talked about finding the volume of cones, and today we are going to talk about finding the surface area of cones. So, when you're finding the surface area, you're thinking about, okay, if I were to take a cone and fully wrap it in wrapping paper, how much would I need? So, the net can be useful here. There are two parts that we need to find the surface area for. We need to find the surface area of the circular base, right? That's what's in orange. And then we also need to find the curved surface going around the cone, and that's what is in blue here. And that's like a sector of a circle. Okay, so the surface area volume, look at that nice straight line, for a cone is pi r squared plus pi r L. So the pi r squared part is that's actually like the orange circle, right? This is pi r squared because it's a circle with a radius r. To find the area of a circle, you do pi r squared, but then you have to add to that pi r L. That gives you the area of that curved surface going around the cone. And I'm not going to talk about that right now, but if you stick around at the end of the video, I'll kind of explain more of where that comes from. Okay, so for right now, we are just going to focus on applying this formula that we have right here. So surface area equals pi r squared plus pi r L. All right, we do not need the height for finding the surface area of a cone. So first thing that we want to do is find the radius of the base. In this case, it is given to me. Okay, my radius of my circular base is 6 centimeters. And then my slant height is that diagonal, that is 10 centimeters. So I just plug this into my formula. Surface area is equal to pi r squared plus pi r L. So pi times my radius is 6 squared plus pi times r is 6 times L is 10. And now I'm just going to enter this just as is into my calculator. So pi times 6 squared plus pi times 6 times 10 gives me a surface area of 301.59. My original units were centimeters, so I'm still in centimeters, and I'm in area, so it's square centimeters. Next, in this case, you'll notice that I am not given my radius. I need to find that actually. So my radius is this red dashed line right here. I don't have it. I need to use Pythagorean theorem. R squared plus 8 squared equals 17 squared. Now you can use Pythagorean theorem to find this. That's fine. You could also remember that this is a Pythagorean triple, or you could remember from when we found the volume of this same cone, the radius is equal to 15. So r is equal to 15. My radius of my base is 15. And then my slant height is given to me. L is 17. So surface area is equal to pi r squared. So pi times 15 squared plus pi r L, so pi times 15 times my slant height is 17. So enter this into your calculator. Super exciting. Pi times 15 squared plus pi times 15 times 17. I got for my surface area, it is equal to 1,507.96 square centimeters. If you got something different in your calculator, you should go back and check how you entered it in. Or if you found a mistake of mine, email me, please. Next, radius of the base. Well, I don't have the radius, but I do have the full diameter. So the full diameter is 10. I need to cut that in half to get my radius. So my radius is 5. Nice. So far, so good. I also don't have my slant height. That is this distance over here. So once again, I can use Pythagorean theorem. I do know that this is a Pythagorean triple, but I'm still going to write out Pythagorean theorem for this. So 5 squared plus 12 squared is equal to L squared. Enter that into your calculator. Remember the Pythagorean triple. You get your slant height is equal to 13 centimeters. So fill that in up there. Now I'm just plugging it into my formula. Surface area is equal to pi r squared, so pi times 5 squared, plus pi rl, so plus pi times 5 times 13. Enter that into my calculator. Oh, I forgot the squared here. I said it, didn't write it. So pi times 5 squared plus pi times 5 times 13 gives me a total surface area of 282.74 square centimeters. Okay, so that is the end of new stuff for today. If you are curious about where the second portion of this formula came from, stick around and I'll tell you now. If you're not, you're good to go. You know how to substitute into a formula. Have a great day. Go do some practice. Do your check for understanding. Email me because you're bored, whatever. All right, so let's add a page on here. Sometimes this makes things kind of messy. All right. So the first thing that I want you to recall is when you are, I don't know what that did. Hope that's okay. When you are finding the surface area of a circle, it's just pi r squared. When you are finding, so that's this. Please hold. Okay, so it's not working on here. I've got a different document up. Hopefully this works. All right, so recall a net looks like it is a circle and then a sector, right? That's hideous. Okay, so I drew our little net here. Still not the best, but it'll have to do. So you know that when you are finding the area of a circle, you just use pi r squared. So for my circle up here, I would just be using pi times r squared, and that's fine. That's the first part of my formula, right? Surface area is equal to pi r squared, it's an r, plus pi rl. Now, the second part of that is what we're confused about, right? Or what we don't know yet, I guess. So think back, if you had just a regular sector, all right? So this is just totally separate, a made up example. If I wanted to find the area of this sector, I would take that 30 degrees, right? That's the central angle right there. And I would put it over 360 and I would multiply that by 18 squared times pi, right? Because it's like this tells you, this 30 over 360 tells you the portion of the circle, the 18 squared pi tells you the full area of the circle. So that's how we would get the area of that sector. The problem that we have here is we don't have actually what that central angle is. So how do we figure out this pi rl from what we're given here? Well, what you do is you take, instead of using like 30 over 360 to find the portion, you use the ratio of circumferences. So this length, the length of this length over here would actually be the same as the circumference of the smaller circle. So I'm going to use the ratios there to help me solve for this second part of the formula. So the circumference of the smaller circle would be 2 pi r. The circumference of the larger circle would be 2 pi l, because L is my radius of that larger circle. So instead of using the ratio of the angles, I'm using the ratio of the circumferences, and then I would multiply that by pi l squared, because L is the radius of the larger circle. So now if I simplify this, my 2's are going to cancel. My pi's are going to cancel, and I'm left with, let me see here, r times pi times L squared, which is really L times L, all divided by L, right? Well, now what's going to happen with one of these L's? It cancels, so I am left with R times pi times L, or if I rearrange the order, pi r L. All right, so that's just a little fun little math problem there to show you how we got that second part of the formula. All right, if you have any questions, feel free to email me. Otherwise, that's it for today. Enjoy the rest of your day. Bye, guys.